In this video, I'll show you how to use the Develocity Analytics dashboard to diagnose and troubleshoot build failures. It will focus on a practical step-by-step analysis to identify and investigate problems within a software development project. Let's begin our specific build failures analysis by setting a strategic date range. Setting a specific date range for the dashboard helps us identify trends and patterns over time. We will set the range to include the last 90 days from the date range selector near the top right of the dashboard. With our date range set, the dashboard updates to show data for that period. Now, to get a clearer picture of where failures are occurring, let's open the Details per Project section. This section provides the raw data we need to analyze. We'll see a breakdown of failures for each project, which helps us focus our efforts where they'll have the most impact on overall delivery speed. Let's focus specifically on the CI builds within this section. These are the automated builds triggered by changes in our code repositories, and their health is a direct indicator of our continuous integration effectiveness. To get a better view of this critical data, we'll maximize the CI builds panel. Open its menu by clicking the 3 vertical dots at the upper right of the panel, then select View. Alternatively, select the panel by clicking anywhere within it, and then use the keyboard shortcut V. We'll start by sorting the table by failed builds by clicking on the header text for this column. Then we'll actually click on the header again to sort by this column in descending order so the projects with the most failed builds are shown first. This gives us a first look at where the largest number of failures is occurring. It allows us to ask initial questions about resource allocation. Notice that the table shows both Maven and Gradle builds, while we are only interested in Gradle builds. So let's now sort by the build tool column. In organizations with mixed build systems, this separates focus among build tools. This is important for architecture and tooling perspectives, and may suggest potential process and knowledge sharing issues specific to Gradle. However, notice that the data is no longer sorted by build failures. Here's a key step. We'll shift-click on the failed builds column while the table is still sorted by build tool. This retains our build tool focus and sorts by the failure count, giving us the most problematic Gradle projects. We're really getting specific about where we need to investigate. Alternatively, and often more simply, you can directly filter the dashboard by build tool to show only Gradle builds. This is done by selecting Gradle in the build tool filter, located at the top left of the dashboard. After filtering, ensure that the table data is sorted by the failed builds column. Notice the top 3 Gradle projects with the highest failure rates: Beam, Kafka, and Groovy. These are potential bottlenecks and risks to our delivery timelines. This signals where intervention and additional resources might be needed. We can now dig deeper to investigate potential tooling, skill set, or dependency issues. Having identified Beam as a project with a high failure rate, we'll now examine its specific failure trends. While Details per Project offers a current snapshot, the Trends section reveals how these failures evolve over time. We'll focus on the failed builds on CI panel within the Trends section of the dashboard. This allows us to observe changes in failure rates over time, which is crucial for identifying emerging issues or the impact of recent changes. Let's expand this panel to full screen by selecting it and pressing V to get a better view and filter the data specifically for the Beam project. Focusing on a single project helps us analyze its specific trends without the noise of other projects. Now, look at the graph legend. We can interact with it to isolate specific data lines. Let's click on Failed to see the overall trend for failures in the Beam project. By isolating this line, we can see if the total number of failures is increasing, decreasing, or remaining stable over the selected date range. We're looking for a definitive trend here. We see that recently there may be a slight increase in overall failures. So further exploration is warranted to determine trends in verification versus non-verification failures. So let's click on Verification Failure in the legend. Verification failures often indicate issues with tests or checks within the build process. Understanding the trend of verification failures can point to problems in the testing infrastructure or recent code changes. No trend is apparent, so we can move on to look at non-verification errors. Observing the trend in non-verification failures can help us understand the nature of the build instability. As described earlier, this type of failure can include things like compilation errors, issues with dependencies not resolving, or problems with the build environment itself. By isolating non-verification failure, we observe a possible recent upward trend for the Beam project. This indicates that while overall failures might not show a strong trend, a specific type of failure is increasing. This is likely worth investigating further with the engineering team to identify the root cause. We need to understand the root causes. Is it a computing resource constraint, time constraint, team experience, process deficiencies, lack of interest in build processes? We can then facilitate improvements through collaboration, process optimization, and training. Develocity Analytics helps you exactly do that and much more.